As long as the money's in place, the gear shaft can be repaired. The Pakistani master can only use 2 ordinary bolts to splice the scrapped gear shaft. This repair method is really rare. The Pakistani cousin in front of him can't disassemble his gear shaft. He has no choice but to cut it directly with sheep ant etching. Unfortunately, there is no spare parts in Peshawar, so he can only ask the repair shop to splice and repair it. Considering that the cut surface is a bevel, the master first uses an angle grinder to cut it and try to make the fracture surface smooth. To reduce the difficulty of subsequent lathe cutting, the gear shaft is then fixed on the claw plate. The gear shaft needs to withstand a lot of torque. As for the hardness of the material itself, it is very high. The master then uses a torch to repeatedly heat the surface. After high temperature annealing, the hardness is reduced, which can improve the efficiency of lathe processing and avoid unnecessary damage to the cutter head. After the remaining shaft is completely cut and removed, the center point of the concentric and coaxial surface that allows the gear shaft to dock must be drilled with a twist drill. It can only be used as a reference splicing point for concentricity. The convex splicing solution can also increase the splicing strength. After processing with a drill and an inner hole cutter, the hole diameter now meets the requirements for docking. As for the broken gear shaft end face, Fu will have to perform the same processing again. Since the previous hole diameter has been enlarged, the hole position on one side must use the same data to prevent the inconsistency between the two sides from causing unbalanced forces at both ends. Following the master's meticulous walkway, the gear shafts at both ends have already passed. The middle of the gear is connected by a shaft. In order to restore its original length, Fu is going to use this enlarged and thickened metal to achieve the solution of docking with the gear shaft hole. After simply measuring the length of the previous cut, Fu also needs to calculate the depth of the 2 holes. This is what is needed for splicing the shaft. After processing with their high-end cutting slot cutter, this section of metal with the right length will be processed into an embedded convex column that is consistent with the hole position. A seamless docking can avoid eccentricity. Then use a caliper to repeatedly measure and compare the hole diameter data and the outer diameter of the convex column. Once there is a gap, it will affect the concentricity of the two. The strength of the hole connection alone is obviously not enough. Fu also needs to mark the point through the center line. The purpose of doing this is to use the screw rod to assist in the connection. When the internal part of Media needs to be locked with the Rome, Fu also needs to drill holes according to the length of the screw rod so that the Rome can completely penetrate the two. Just after the drilling of the lifting drill, in order to allow the Rome to tighten from the side, the master also needs to use a drill to make a horizontal hole. The 2 holes can be connected, but the Rome is thicker than the rod, so a marked drill bit is needed to expand it to prevent the hole from being too small to be fixed. After confirming that there is no error in the horizontal hole position, the hole position must be pressed with a marked tap according to the rod tool. However, this maintenance is only for splicing, and each step of processing cannot be separated from accurate data. After the master quickly finishes the pressing, the screw rod must be screwed to the bottom with a wrench to prevent the hollow bone inside the hole from affecting the splicing strength. Under the full pressure of the hydraulic press for 3 minutes, the Media has become a part of the gear shaft. The hole in the direction just allows the bare rod to be completely exposed. Then connect the bare nut with the bare rod and tighten it completely with a small wrench. The strengthening of the nut fixation, the hollow hole will also affect the use of the gear shaft. The part needs to be filled with a high hardness welding rod. The hole can be completely covered by the welding bar. There is still a slight error in the appearance of Media. The surface of Media needs to be cut and cut continuously. The previous welding bar can disappear, and the glossiness of Media can be improved. For the whole of the other section of the gear shaft, the tail of the steel should be processed with a precise convex column. Considering that the subsequent gap needs to be welded and reinforced, the outer edge of the A-ring should be cut out to increase the welding area. After the finely processed A-ring is coated, it can be connected with the other section for hole position, then put a layer of steel pipe into the tail gear, and then fix it with the claw plate for welding reinforcement. The weld scar on the surface of the groove will be processed and modified with the original outer diameter until there is no trace on the surface. This is the rigor of the Pakistani master. The shaft rod cut in the middle is filled with round steel. After confirmation, the fixed steel pipe is separated. Then the gear shaft that has been cut is filled with a round steel to complete the splicing. What do you think of the bolt fixing solution?